following information is brought to you by the Dots of Fire. We are Yumiko, Julia, and Zoe from Laura Geiser's first period physics class, and this is torque in plain English. So what exactly is torque? Torque is the force that changes the rotation of an object. It depends on several factors. The magnitude of the force, so the bigger the force, the bigger the torque. The direction of the force, i.e. the direction of the lever arm, and the location of the force. The farther from the axis of rotation, the larger the torque, so less force is needed. The formula for torque is T equals Rf, where T is torque, R is radius, and F is force. The radius is the distance from the axis of rotation to the point where force is applied. At this point, you may be wondering, how is torque applied in the real world? Take a seesaw, for example. For festivity, we will demonstrate it using Easter eggs. A 1 kilogram egg sits at the end of a light 5-meter seesaw. The seesaw pivots at its center point. How far must a 3 kilogram egg be placed from the pivot to achieve rotational equilibrium? To solve this problem, one must first locate the position of the pivot point. In this case, the pivot point is at the seesaw center. One can use this information to find the radius. Since the radius is 1/2 the diameter, or the length of the seesaw, the radius is 1/2 of 5 meters, which is 2.5. This is the radius of the 1 kilogram egg as it sits at the end of the seesaw. Next, one can set up an equation. Since the objective is to try achieving rotational equilibrium, the net torque, or sum of the torques, is 0. Therefore, the equation should be 0 equals T1 plus T2. To balance the forces on the seesaw, for simplicity's sake, have the force going counterclockwise be negative, and the force going clockwise be positive. With that established, one can plug in the variables into the equation. So the 3 kilogram egg must be placed 0.833 meters from the pivot to achieve rotational equilibrium. Okay, simple enough. So what if the pivot point is not centered? For example, 2 eggs are placed on a light 5-meter board. The 3 kilogram and the 1 kilogram egg sit on opposite ends. How far from the 3 kilogram egg should the board be pivoted so that it does not rotate? In this situation, one must use variables. The distance of the 1 kilogram and the 3 kilogram egg must be equal to 5 meters. Therefore, R1 plus R2 equals 5. To solve for one variable, change the equation to R1 equals F minus R2. Using the same equation and concept from the previous problem, plug in the variables. Your answer should be R2 equals 3.74 meters. This is not the final answer though. This is the radius of the 1 kilogram from the pivot point. So solve for R1. R1 equals 5 minus R2, and you should get R1 equals 1.26 meters. This makes sense because a lighter object should be placed farther from the pivot and the heavier object should be placed closer to the pivot point to maintain rotational equilibrium. In conclusion, if torque is a constant, then the larger the radius, the less force is needed to obtain the required torque. Likewise, for a smaller radius, more force is essential for the same torque. Now that you know what torque is, you can go out and party with your friends.